Last section, section 9, the work of wind. We are going to talk about key terms: deflation, blowouts, desert, pavement, loess, dune, slip phase, and a cross bedding. And a cross bedding is one of your homework question here. First of all, you need to be knowing that the wind erosion, to be effective, dryness and rare of vegetation are essential. We have different kind of erosions and by wind deflation, which means that the lifting and the removal of loose material, which often produces shallow depressions called blowouts, and can also lower the surface by removing sand and silt. And we have a video here which is going to talk about how actually wind can be able to transport the sediments.
NASA scientists have performed the first multi-year study using satellite data to measure the 3D distribution of dust that travels from the Sahara Desert to the Amazon rainforest. The Sahara is the world's largest desert. At more than 3 million square miles, is almost the size of the continental United States. Each year, Saharan dust is lifted from the ground and transported by winds on a 3,000-mile journey across the Atlantic Ocean. A portion of the dust collects in the Amazon basin, the largest rainforest on the planet. Although dust particles are small, no larger than around a tenth of the width of a human hair, they form massive plumes that can be seen from space. NASA's Calypso satellite was launched in 2006 to study the vertical structure of clouds and particles in Earth's atmosphere. Calypso observations from 2007 through 2013 show that on average 182 million tons of dust leaves Africa each year. Of this amount, about 27 million tons is deposited in the Amazon basin.
Sahara dust contains phosphorus, which is an important nutrient for plants. In the tropic region, the phosphorus is quite limited, so it's important to estimate how much dust from desert is transported to the Amazon.
The study shows Saharan dust adds phosphorus to the soils that help compensate for losses due to surface runoff and floods. However, the amount of dust transported to the Amazon changes from year to year. According to the study, this variation is closely associated with changes in rainfall in the Sahel, a belt of semi-arid land just south of the Sahara.
When the Sahel was dry, the dust transport to the Amazon in the next year would increase. When it was wet, dust transport will decrease. Using satellites to get a clear picture of dust is important for understanding and eventually using computers to model where that dust will go now and in future climate scenarios.
And also there is a section where it's going to talk about the wind deposits, which is really important to analyze Asian deserts, right? Wind deposits, they have distinct two types: extensive blankets of silt, and they're called loess, and they form when a wind deposit is suspended load. And secondly, we have mounds and ridges of sand called dunes, and that's forming when a sediment that was carried as part of the wind's bed load accumulates. And I would like you to watch this video showing you how the crossbedding is defined at the field. And now you can do your homework.
Hello, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the main mechanism by which wind moves sand dunes. One thing we know about sand dunes is that they don't stay put. They tend to move over time. And we also know that wind is capable of moving the very small grains of sand that compose a sand dune. If we happen to be near a sand dune on a windy day, we might actually even see sand grains moving. Here you can see little sand grains bouncing along the surface of the dune as they're carried along by wind. They're carried a short distance and dropped, and then they're carried a short distance and dropped. They're saltating over the dune surface. This is the way that wind moves dunes, one grain at a time. Wind blows over the gently sloped back sides of dunes and picks up sand grains there. Then in the lee of the dune, on the side that's facing away from the wind, where the wind energy is a little bit lower, new layers of sand grains are deposited on that face. That's called the slip face, because basically the sand grains are piled up there until suddenly they slip. This is what it looks like when they slip. There's a little avalanche that runs down the slip face of the sand dune. Many, many, many of these little avalanches end up being built out over time to produce what in cross-section appear as little lines. These are crossbeds, and we've seen crossbeds before when we studied sedimentary rocks. If the wind direction changes, say from left to right back to right to left, then the direction of those crossbeds is going to change as well. So you can see some of the crossbeds here are inclined towards the right, and then the more recent set are inclined towards the left. Here's an example of some of these fossilized crossbeds. These are in the Navajo sandstone in Zion National Park. And you can see the main beds are units like this, and then within them are these beautiful crossbeds, which are inclined in the downwind direction. So basically these are the preserved slip faces of ancient sand dunes. Okay, to test yourself here, we've drawn a little Barkhan dune. Make a prediction about which way this dune is going to move if we let the wind blow on it. Well, Barkhan dunes form in a very specific orientation relative to the wind. So if you've studied that portion of the chapter, you know the wind's got to be blowing from the left towards the right, picking up sand off the back of the dune and then dropping it on the slip face. Over time, that's going to cause the dune to move. All right, so it's not moving as a single bodily mass, but one grain at a time, this dune is going to be moved from the left towards the right, from upwind towards downwind. Thanks very much for your attention. This has been another Smart Figure.